Hi there, folks. My name's Saul, Dr. Saul, the solving surgeon, and I'm here to talk to you about solving two-step equations. Now, I got a question. Why did the pillow go to the doctor? Because he was feeling all stuffed up.
First vocabulary term is a variable. That's a symbol, usually a letter, that can be any given value. So here you can see we have an equation, and in our equation we have this letter that is multiplied to 3. This letter represents any given value. So you could plug in any number for x, simplify this, and see if both sides are equal. Or you could solve this for x, get x by itself to determine what value of x would make this equation true. The second vocabulary term is a constant. That's a specific number. So if you're looking down here, anytime you see a number, we call that a constant in math. That's just another way for math teachers to make it harder on you. Instead of just calling it a number, we call it a constant because it's a never-changing number. A coefficient is going to be a number placed in front of and multiplied to a variable. So here you can see we have 3 times x. The 3 is a constant, but since it's multiplied to the x, our variable, it's also called a coefficient. Next vocabulary term is an equation. That's a statement that the values of two mathematical expressions are equal, indicated by the equal sign. So we look down here and we see that negative 2x plus 5y is equal to 12. This is an equation because we have two expressions, negative 2x plus 5y and 12 set equal to one another. Same thing with each of these. We have two expressions set equal to one another. That's what constitutes an equation. Solving equations. So when solving equations, our goals are to simplify, move, solve. So just remember this, SMS, simplify, move, solve. First thing we want to do is simplify each side if possible. Next, we're going to move the variables to the left-hand side of the equation. After we've done that, we're going to move the constants to the right side of the equation. Lastly, we're going to solve for the variables. So again, simplify, move, solve.
What did the urologist tell all of her new patients? You're in good hands. It's example time.
Example 1 says solve the following equations. Here we have 3x plus 3 is equal to 18. So in order to solve an equation, we need to simplify, move, solve. So first, we're going to simplify each side if necessary. This side over here, can we simplify this? No. This has an x, this does not. So it's as simplified as it's going to get. Same thing over here, this is just 18, so that's already simplified. Next, we need to move the variables to the left-hand side of the equation. It's already over here. Now the constants have to go to the right. So we're going to start with anything added or subtracted to our variables. So we're going to start with this plus 3. How do I move a plus 3 to the other side of the equation? Well, since it's plus 3, I have to do the opposite of that to move it. So I'm going to subtract 3 from both sides of the equation. Now, why do I have to subtract 3 from both sides of the equation? Because it's an equation. So whatever you do to one side of an equation, you must do to the other side, otherwise it would not be equal. Now, this plus 3 and this minus 3 cancel each other out. They're inverse operation. And I'm left with 3x is equal to, and what's 18 minus 3? 15. Now again, I still need to get all of the constants to the right-hand side. So this 3 needs to get over here. How do I do that? Well, this is 3 times x. In order to move the 3, I have to do the opposite of multiplying. I need to divide both sides by 3. Now I do that because these are inverse operations, so the multiplying and dividing, the 3's are going to cancel each other out now. And I'm left with 15 divided by 3, which is 5. So x is equal to 5. And I'm done. I've solved the equation. Now, when you solve an equation, you can always check your answer to see if you did it right. In order to do that, all you have to do is take this 5 and plug it back in the original equation for x. So I'm going to take the 5, plug it in for x. Now I'm going to simplify this. I'm going to multiply the 3 and the 5. I get 15, and then I'm going to do 15 plus 3. According to the order of operations, I have to multiply before I add or subtract. So 15 plus 3 gives me 18. Now 18, does that equal 18? Yes, so that means we did it right. Now part B says 6h minus 7 is equal to 17. So again, simplify, move, solve. That's how you solve an equation. So simplify. Can I simplify this side of the equation? No, this has an h, this does not, so I can't subtract these two. This is 17, it's already simplified, so that step is done. Now I need to move the variables to the left-hand side of the equation. Well, this is the left-hand side and our variable is already here. Done. Now I need to move the constants to the right, so this is where the work starts. I'm going to start with anything added or subtracted to our variable. So this minus 7 is going to go first. How do I move that over here? Well, you do the opposite. What's the opposite of subtracting 7? That would be adding 7. So I'm going to add 7 to both sides of the equation. Now when I do that, minus 7 plus 7, those are inverse operations. Those cancel each other out. And over here, 17 plus 7 is going to give you 24. Now, I need all of the constants to go to the right. So in order to get rid of the 6, what I have to do, it's 6 times h. So I have to do the opposite of that. What's the opposite of multiplying? multiplying, that would be dividing. So I'm going to divide both sides by 6. And when I do that, these 6's are going to cancel each other out. And over here, 24 divided by 6 is going to give me 4. So I have h is equal to 4 as my final answer. Now, did we do it right? Let's check. We take our original equation. I'm going to plug in 4 for h. Now we simplify. So order of operations says parentheses first, nothing doing there. Exponents, nope. Multiplying or dividing. Yes, we can multiply these two, we get 24. And then adding or subtracting 24 minus 7 is going to give us 17. So does 17 equal 17? Yes, we did it right.
Does an apple a day really keep the doctor away? Only if you have really good aim. You try.
Okay, so again, when solving equations, we need to first simplify, then move, then solve. Simplify, move, solve. Step 1, simplify each side if necessary. So we look over here. Can we simplify this side of the equation? No, this has an x and this does not, so we cannot subtract these two. Over here, this is already a 16, so that's simplified. Step 2, the variables need to go to the left-hand side of the equation. Here's our x, that's our variable. It's already on the left-hand side of the equation. Done already. Step 3, get the constants to the right-hand side. Over here, we have a 4 and a minus 8. We need those to go to the other side of the equation. We start with anything added or subtracted to our variable, so that would be this minus 8. How do I move a minus 8 to the other side? I do the opposite. I add 8 to both sides. And when I do that, these are going to cancel out. And over here, 16 plus 8 is 24. Now again, we're moving the constants to the right. So how do I move this 4 to the right? Well, it's 4 times x. So I have to do the opposite of that, the inverse of that. So I'm going to divide both sides by 4. Now, when I do that, these are going to cancel out, and I'm left with x over here. And on this side, 24 divided by 4 is just going to give me 6. Now again, this is our answer, and you can always check your answer. What you have to do, take the number that you got, plug it back into that original equation. And now I can just use the order of operations to simplify this and see if I get 16. Parentheses, yes, but there's nothing to do inside the parentheses. What about exponents? No. Multiplication or division? Yes. You multiply 4 times 6, you get 24. Then addition or subtraction, 24 minus 8 is going to give me 16. And yes, 16 equals 16, therefore we got the right answer. Part B, simplify, move, solve. Can we simplify this over here? No, this has an n, this does not. This is 20, so that's already simplified. Done. Step 2, variables on the left-hand side of the equation. It's already there. Step 3, constants need to go to the right. So I'm going to start with anything added or subtracted to my variable. So this plus 1 has to go to the other side. And how do I do that? I do the opposite. Subtract 1 from both sides. Now these are going to cancel out. And over here, 20 minus 1 is going to give me 19. And look at that. There's nothing multiplied to our variable, so n is equal to 19. That's our answer. Now we need to check our answer. So we go ahead and take that 19, plug it back in the original equation for n, and we can simplify. What is 19 plus 1? 20. So 20 equals 20. We're done. Okay, example 2. So solve the following equations. We have 32 is equal to 5 minus 3t. So again, solving an equation, we need to simplify, move, solve. First, simplify each side. This is 32. Already simplified. Over here, 5 minus 3t. Can we simplify this? Can we subtract these two? No. This has a t and this does not. So we just leave it. Move to step 2. Variables need to go to the left-hand side of the equation. So here, if we have something like this, where our variable is on the right-hand side of the equation and there's no other variables in the problem, we have two options. One, you could add 3t to both sides of the equation, and that would be 3t plus 32 is equal to 5. Or just flip the whole equation, switch the sides. So I'm going to take this 32 and move it to the other side. So it's going to be 5 minus 3t is equal to 32. These two equations are equivalent. Now we can go on. Since our variable is on the left-hand side of the equation, we can do step 3, which is constants need to go to the right. And again, we start with anything added or subtracted to our variable. So here that would be this 5. Now, this is a positive 5. It's weird because it's not negative 3t plus 5, right? It's 5 minus 3t. So since it's positive 5, in order to get it to the other side, we have to do the opposite. What's the opposite of positive 5? That's negative 5. So we're going to subtract 5 from both sides of the equation. That way, these cancel each other out. Over here, 32 minus 5 is going to give me 27, and this stays negative 3t. Remember to keep that negative with our 3. Now we need to get t by itself, right? All of the constants have to go to the right, so this negative 3 has to go as well. So we're going to divide both sides by negative 3. Again, why do we do that? Because these two are multiplied together, so we have to do the opposite, the inverse. So we divide both sides by negative 3. These are going to cancel out, and 27 divided by negative 3, since one's a positive, one's a negative, our answer is going to be negative, and 3 goes into 27 9 times. So our answer is t is equal to negative 9. Again, check your answer. Take negative 9, plug it back into the original equation for t. So instead of t, I'm going to put parentheses around negative 9. Now I'm going to simplify this and see if I get 32. So we start with our order of operations. Parentheses, nothing to do in here. Exponents, no. Multiplication or division, yes, we need to multiply first. Okay, do not subtract these first. It's order of operations, so we multiply first. What is negative 3 times negative 9? That's going to be positive 27. And now what is 5 plus 27? 32. Boom, got the right answer. Part B, we have 50 is equal to 100 plus 2x. So again, simplify, move, solve. Can we simplify 50? No. Can we simplify 100 plus 2x? No. This has an x, this does not, so we cannot add those together. Next, move the variables to the left. What I recommend, again, is if you have something like this, where our variables on the right-hand side, just flip the equation. So instead of 50 equals 100 plus 2x, it's going to be 100 plus 2x is equal to 50. It means the exact same thing. Now our variable's on the left, so we move our constants to the right. So first, anything added or subtracted to our variable, we move first. So this 100 has to go. Since it's a positive 100, we're going to do the opposite. We're going to subtract 100 from both sides. Now these cancel out, and here, 50 minus 100. Don't write 50. It's negative 50, right? Because you're taking 100 away from 50. You're taking a bigger number away from a smaller number. So your answer should be negative. Now we get x by itself by getting rid of this 2. And again, it's 2 times x. So how do we get rid of it? We do the opposite, the inverse. We divide both sides by 2. These are going to cancel out, and we're left with x is equal to negative 25. And we need to check our answer. How do we check our answer? We take negative 25, plug it back in for x. From here, we can simplify 2 times negative 25. What's 2 times negative 25? That's going to be negative 50. Again, it's order of operations, so do not add these two together first. You need to check for parentheses. Nothing doing here. Exponents? Nope. Multiplying or dividing? Yes, you can multiply these two and you get negative 50. Now, what is 100 minus 50? That's going to be 50. Boom. Got it.
What happened to the optometrist who got stuck in the lens machine? Oh man, it was a spectacle. You try.
Okay, part A. Simplify, move, solve. Can we simplify? No. Can we simplify? No. This has an x, this doesn't. Next, variables have to go to the left. Since our variable's on the right at the beginning of the problem, I can just flip this equation. So it looks like this. 8 minus 2x is equal to 10. Now our variable's on the left, so we move the constants to the right. Start with anything added or subtracted. So we start with this 8. Since it's positive, we're going to do the opposite. We're going to subtract 8 from both sides. These now cancel out. Over here, 10 minus 8 is going to give me 2. Now, to move this negative 2 to the right, it's negative 2 times x, so I do the inverse. I divide both sides by negative 2. These cancel each other out, and over here, 2 divided by negative 2 is going to give me negative 1. Again, I can check my answer. Take negative 1, plug it back in the original equation for x. Order of operations, PEMDAS, parentheses, nothing to do in here. Exponents, no. Multiplying or dividing, yes, you can multiply this negative 2 to this negative 1 and get positive 2. Now we add or subtract, so add 8 plus 2 gives me 10. 10 equals 10. We did it right. Part B, we have negative 0.5 is equal to negative 4.1 plus 1.8w. Simplify, move, solve. Can we simplify this? No, it's just a constant. Can we simplify this? No, this has a w, this does not. So we can't simplify. Next, we move. Move variables to the left. Anytime you have something like this, we said our variable's on the right-hand side and there's no other variable, so I can just flip this equation. So I take this negative 0.5, put it on the other side, and write negative 4.1 plus 1.8w is equal to negative 0.5. Now I have to move the constants to the right. So how do I do that? I start with anything added or subtracted to our variable. So that's going to be this negative 4.1. Since it's negative, I'm going to do the opposite. I'm going to add 4.1 to both sides. Now these over here cancel each other out. I'm left with 1.8w is equal to, and then when I add 4.1 over here, I end up getting positive 3.6. Now again, it's 1.8 times w. So to get my last constant to the right, I have to do the opposite, the inverse of multiplying by 1.8. I'm going to divide by 1.8. That way these cancel out, and remember, whatever I do to one side, I have to do the other side. And I'm left with w is equal to 2. Now again, I can check my answer by taking that 2, plugging it in the original equation for w. Order of operations, PEMDAS. Anything I can do in the parentheses? No. Exponents? No. Multiplying or dividing? Yes. Multiply these two, and then addition or subtraction. I can add these two together. Negative 4.1 plus 3.6 is going to give me negative 0.5. And does negative 0.5 equal negative 0.5? Yes, we did it right. Example 3, we need to simplify, move, solve. Can we simplify this side? No. Can we simplify this side? No. Step 2, move variables to the left. Done. Step 3, constants to the right. This 1/2 I need to get over here. How do I do that? A couple different ways. But the easiest way that I found, anytime you have a fraction in your problem, to get rid of that fraction, you're going to multiply both sides of the equation by that denominator. If there's more than one, you're going to have to find the least common denominator. But what's good about this lesson is that there's usually only one fraction, meaning your denominator of that fraction is the least common denominator. So our least common denominator here is 2. So what I do is I figure out the least common denominator and I multiply both sides of the equation by the least common denominator. Here's why. This 2 and this 1/2 are just going to cancel each other out and leave me with y. Over here, 2 times 8 gives me 16. If you didn't know that these cancel out, you could multiply it like normal. 2 is the same as 2 over 1, so then I multiply the numerators together and denominators together. So 2 times 1 gives me 2, and 1 times 2 gives me 2. So I get 2 over 2y is equal to 16. Now what's 2 divided by 2? 1, and 1y is the same as y. We're done. Part B, doing the same thing. Simplify, move, solve. Can we simplify this side? We can't add these together, so no. This has an x, this does not. And over here, this is 11, so no. Step 2, variables on the left. Done. Step 3, constants to the right. So the 5 and the 3 both need to go this side. I said, anytime you have a fraction in your problem that you need to get rid of, what you do is you multiply both sides by the least common denominator. Here, there is only one denominator, just like we were talking about. It's 3. So I'm going to multiply both sides of the equation by 3. Now, if you didn't realize that these cancel out and you could just get x plus 5 is equal to 33. If you didn't realize that, 3 is the same as 3 over 1. So you multiply the numerators together and denominators together. So 3 times x gives you 3x, and 3 times 5 gives me 15. And then 1 times 3 in our denominators gives us 3. So it looks like this. If you didn't realize these canceled out, you could still simplify this by breaking it up into 2 separate fractions. So the 3x goes over 3, and the 15 goes over 3. These 3's are going to cancel each other out. 15 divided by 3 gives me 5. From here, I can subtract 5 on both sides to get x all by itself, and I get x is equal to 28. Again, you can make it way easier on yourself if you realize that because we're multiplying both sides by the least common denominator, these 3's are just going to cancel each other out.
Oh man, this is not looking good. You should try.
Simplify, move, solve. Step 1, can we simplify either side? No. Step 2, move the variables to the left. Done. Step 3, constants need to go to the right, so this needs to go over here. How do I do that? 2 different ways. One would be to multiply both sides by the reciprocal. If you don't know how to do that, then you do exactly what we were just doing. We find our least common denominator. Since there's only one denominator, that's the least common denominator. 5, we multiply both sides by the least common denominator. 2 ways to do this. One would be to figure out that these 5's cancel each other out. The second would be to just multiply it. 5 over 1 times 2 over 5 gives me 5 times 2, 10 over 1 times 5, 5. Over here, 5 times 20 gives me 100. 10 divided by 5 just gives me 2. Now again, get all the constants to the right by moving this 2. How do I do that? It's 2 times w, so I do the opposite, the inverse. I divide both sides by 2. These are going to cancel each other out, and I get w is equal to 50. And I'm done. Part B, simplify, move, solve. Can we simplify this? No. This has an x, this doesn't. This is already simplified, done. Step 2, variables on the left, done. Step 3, constants need to go to the right. Anytime you have a fraction like this, we multiply both sides by the least common denominator. Good thing is, there's only one denominator. It's 9. So I'm going to multiply both sides by 9. 2 ways to do this. One would be to realize that these cancel each other out. If you didn't realize that, you can always distribute the 9, just like you normally would, and you end up getting 9x minus 9 over 9. Then you can break up into 2 separate fractions, the 9x over 9 minus 9 over 9. These cancel out, these cancel out. And again, just because these cancel out, that doesn't mean they go away. When something cancels out like this, it means turns into 1. So I get 1x minus 1. What I can do then is I can solve for x, finish the problem, by adding 1 to both sides. These are going to cancel each other out. Over here, negative 18 plus 1. It does not make it negative 19. This is positive, this is negative. So I'm going to get negative 17. Now that I got my answers both here and here, remember you can always check your answers by plugging them back in for the given variables and solving and seeing if you get those same things. And if you do, you get the right answer. Step 4 says write an equation, then solve for the missing number. So it says 7 less than twice a number equals 19. 7 less than twice a number. So our number, we can call any variable we want. We can call x, we can call y, whatever. Here, we're going to stick with x. Twice a number means 2 times a number, so it's going to be 2 times x. 7 less than twice a number means you take 7 away from twice a number, so 2 times x minus 7 equals 19. Now I can solve this, simplify, move, solve. Already simplified, move. Do we need to move the variables? No, it's already on the left-hand side. Done. Constants need to go to the right, though. Anything added or subtracted, you start with first. So minus 7, I'm going to do the opposite. I'm going to add 7 to both sides. These cancel out. I get 2x is equal to 26. Now, again, I need this 2 to go the other side. How do I do that? It's 2 times x, so I do the opposite, the inverse. I divide both sides by 2. These cancel each other out, and I get x is equal to 13. Again, check your answer if you need to. Plug this 13 back in for x. You can see that you got the right answer. Part B says 12 more than 4 times a number equals 100. 12 more than means 12 plus 4 times a number. Our number we'll call x, so 12 plus 4x, or 4x plus 12 equals 100. Remember, you can flip these because the commutative property works with addition. Now we need to simplify, move, solve. Can we simplify this? No. Can we simplify this? No. Already simplified. Step 2, variables on the left. Done. Step 3, constants to the right. So I need this 12 to go over here. I'm going to do the opposite. Since it's adding 12, I subtract 12 from both sides. These cancel each other out. I get 4x is equal to 88. Now again, we're moving the constants to the right. So how do I move this 4 to the right? Well, that's 4 times x. So I have to do the opposite of that, the inverse of that. So I'm going to divide both sides by 4. And these cancel out. I get x is equal to 22. Again, check your answer if you need to. Now let's do our word problem. It says a car rental company charges $50 plus $2 per mile. If Jack's total cost was $84, how many miles did he drive? So anytime you get a word problem, we need to first define our variable. What's our variable going to be? Well, what are we trying to find? It says how many miles did he drive? So if we're trying to find out how many miles, let's say M is going to represent the number of miles that Jack drove in his rental car. That's what we're trying to find, so that's what we'll solve for. Next, we're going to use that variable to write an equation. So it says a car rental company charges $50 plus $2 per mile. 50 plus $2 per mile would be 2 times M, the number of miles. If the total cost was $84, 84 then is going to be our total. So we're going to do 50 plus 2M is going to equal 84 because that was the total cost. Now all we have to do is solve this equation for M. Simplify, move, solve. So step 1, simplify both sides. Done. Step 2, move the variables to the left. Done. Step 3, constants need to go to the right. So we're going to start with anything added or subtracted. So this 50, since it's positive 50, I'm going to do the opposite. I'm going to subtract 50 from both sides. I'm going to do that. I get 2M is equal to 34. Now I need to get M by itself. How do I get M by itself? I need to get this constant to the right. 2 times M. I'm going to do the inverse of that. So I'm going to do the opposite. I'm going to divide both sides by 2. When I do, these 2's are going to cancel each other out and I get M is equal to 17. Don't leave this as your answer. You were asked a word problem, so answer it a sentence. M is equal to 17. What does that mean? Well, it means that Jack drove 17 miles in the rental car.